Hello students, let's discuss network speeds, part of topic 4. 4.15 is the reference, Edexcel GCSE computer science. So there are a number of things we need to be aware of here. Network speeds are measured in bits per second. A bit is just a 0 or a 1. Remember, a byte is 8 bits, right? That's 1 byte. Something like that. It's going to have 8 zeros and ones, 8 bits. So you've got to be really careful there. So it's typical that we might measure internet speeds in megabits per second, a million, but you could also have K or Gbps. It makes things seem faster than they actually are, especially for marketing. People don't know the difference between bits and bytes a lot, so often you hear those terms being used. So that is, you've got to be really careful here, because obviously a megabit is a million, mega, kilo, 3 zeros, and you just add 3 zeros every time. Alright, just think of kilogram, 1,000 grams. And what we want to be doing is remembering this equation. So time equals size of file, let's say it's an MP3 file, in bits, not bytes, divided by the network speed. And they might call that transmission rate. Okay, so I'll put in here transmission. They might use that. So what we've got to be mindful of is that it's essentially, look, this is the way to remember it. Speed equals distance divided by time, isn't it? So if you rearrange this equation, so you've got time over here, you can have distance divided by speed. And that's essentially what we've got here. That's the best way to remember this. So if we needed to work out the speed, then we just use speed equals distance divided by time. If we needed to work out the time, then we just rearrange the equation. So what we can do, let's have a look at some examples. A network speed has a speed of 17.08 megabits per second. Okay, so we know that that's an Mbps. Identify the equivalent speed in bits per second. So I would think, okay, what would be 1 megabit per second? Well, that would be 1 with 6 zeros. You've got to remember these. Mega. So 1 times 17 is going to be this one, isn't it? There's our 6 zeros. 2, 3, 4, 5, 6. And the others, that's a gig. And that would be K, so definitely not that one. Latency is what we learned in the last video about the delay. Imagine if you're watching the news, Sky News, they're talking to a reporter in the States, and you're from England, and there's a little delay between the point they reply. That's the latency. Construct an expression to calculate the transmission rate in megabits. Be careful, we're talking about bits here. Required to transmit a 1.4 gigabyte file. Okay, right. So this is not gigabyte. This is related to base 2, isn't it? So if you remember, 2 to the power 0 is 1, 2, 4, 8, 16, 32, 64, 128, 256, 512, 1024. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 2 to the power of 10 is 1024. Alright, 1024. And if you had kebibyte, that's 1024. MIB is 1024 to the power of 2. And then GIB, 1024 to the power of 3. So we're going to be using that somewhere in our expression. And what are we looking for? Calculate the transmission rate. So that's, remember I said to you they might use words like transmission instead of network speed. So transmission rate. So what we want to do is just do our speed equals distance divided by time here. So speed equals distance divided by time. Distance is like the size of the file. Size over the time, right? So what is the time? Well, that's easier, isn't it? That's easier for us. It's at 13 minutes. So we're going to start our experiment. Remember, we don't have to do the calculation here. So 13 times 60. We're going to need to do that at some point because we've got to get our seconds. But remember, the transmission, the time is going to be in megabits per second. So we need to times that by 1,000,000. Okay, 6 zeros. So another way of saying that is 1,000 squared. So I'll put that here. Can you see that? Equals 1,000,000. So that's going to be at the bottom as our time. And then we want the size of the file. Okay, so what's the size of the file? It's definitely 1.4 times something. 1.4. And we need to make it, so we've got to be careful here because remember it's in the transmission speed is, it wants bits, not bytes. So if I, we're just going to deal with the byte part for a minute. There are 8 bits. 8 bits equals 1 byte. So if there are 8 bits and 1 byte, we need to times that by 8, and we also need to make it a gibby. So 1024 to the power of 3, and that's going to give us our transmission rate, our speed. You do not need to do this calculation. There's no need to do that. So we've got at least a mark for this bit will be a mark, this will be a mark, and this whole bit will be a mark. That will give us our 3 marks, and there'll be the whole thing. If the whole thing is correct, it's our 4th mark. Let's look at another one. Construct an expression to calculate the minimum transmission rate required to transmit a 250 mebibyte, MIB, not megabyte, so MIB file in exactly 1 hour. So it tells us how many seconds are in 1 hour, which is helpful. So again, speed equals distance divided by time. It's the transmission rate we're looking for, which is, you know, this idea of network speed. You know, we could say network speed equals size over time. So numerators and denominators here. We know we've got 360 for sure at the bottom. That's a nice easy win, right? That's our time in seconds. We're done. Our top part, our size of the file, is the tricky bit, isn't it? So what's the size? It's definitely going to be 250, but we also, remember, we've got 8 bits per byte, so we want to times that by 8, because we're not dealing with bytes, we're talking about bits here. And we also need to times that by the mebi part, which is 1024 to the power of 2. You could also write 1024 times 1024, and that would also be fine. You've just got to memorize these. You've got to memorize them, I'm afraid. I think it would at least memorize these before your exam. And for topic 4, be prepared to convert bytes to bits, and there are 8 bits in a byte. That's the part that could throw you off. I mean, this in itself is going to be at least a mark. That's going to be a mark. That bit's going to be a mark, and that bit's a mark, and that's going to give us our 3 marks. All right, good luck.